Dun 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 dun. Dun 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 dun. Do-do-do. Do-do-do. Varmint Linear, made by Brewer Labs, P.O. Box 12, Porter, Oklahoma. Delicate instrument. Handle with care. This gentleman here has called me a lot, I guess would be the best way to put it without being rude. He is one of my friends. I do like him. He's a good guy. It's just he has a tendency, like, if for some weird reason I'm having a bad day with a customer, immediately after I get done having a bad day with a customer, this dude's going to call and get an update. Where am I at? I'm like, dude, quit it. Or I get 150 phone calls. 2 are going to be from this guy. And he is the sweetest, most tender guy, and he's just got the worst freaking timing. I'm just saying. He sent up his varmint for I don't know why. And we're going to look at it from top to bottom. So first thing we're going to do... Ow! Ow, it's heavy. And I'm old and feeble. We're going to go over here and we're going to get 747. 747 coming out of the sky. Take me on a move, let's go. Okay, 747 tube tester. And let's test some tubes. 6 tubes here that say 80, 80, 90, 80, 85. These are 6LR6s, 90, 80, 83. These say 120%. 100%, 90%. 80%, 70%, 80%, 80%, 85%, 75%. Let's randomly grab one. And let's slide it out of its protective condom sheath. Modulator tubes. Here, this one says it's 100%. So the 6LR6. 6LR6 goes here. Let's see, power off. 6L A B C D E F G H I J K L. Okay, so we're going to set the heater to 6, sensitivity to 53. Socket 21, clear, powered up. And we'll let it warm up. Tune's warmed up. Test 1, test 2, grid short. Good emissions. Nothing. 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 Here we go. 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 And this is supposedly it's out of the 100% sleeve. It takes its time, and it's moving along. Looks like 100 to me. I'd say it's a solid 70%. Oh man. I was so hoping that all of these would be as packaged. They're not. Okay. See, this has been here and been tested by me. BBI 100%. Oops, sorry. It's written right there on the glass. BBI 100%. So that tells me that this amp, I know which amp this is. I remember this amp now. He brought it here and we tested all the tubes. It took all afternoon. Ended up having a family deal to go to because he was having problems with his key-in circuit. Then he wanted to convert it over to 220. I told him it'd be better if he did single phase. I know what we got going on now. Oh, shoot. Oh! I'm over here making a stickity-ick. Check this out. I mean, I'm 1 millimeter away from flowing over on that jar. Okay, well, let's turn this on. Let's let that warm up. And, yeah, we shall return. Now, this little guy just tested at 120%. Pegged this thing in the corner. So I better check them all. Because I don't know what the status is here. I don't understand what's going on. Let's throw these in the shipping container that they came in, because they're going to go back in the same packing material. Let's let it warm up. This just takes forever to get done. This is a very time-consuming process. I'm here to tell you, oh man, my window screen rubber broke. Son of a fart snack potato muncher. Okay, I'm here to tell you that was interesting results. I had one tube that was over 100%. I called my guy. I said, hey, dude, tell me what the story is with your amp here. He says, this is a completely different varmint than what I had here before. But he sent me up tubes that I had already tested. So that's the reason they had all these high gain numbers to them. The problem is none of these tubes tested, all but one, tested way lower than what was written on the tubes. And I mean not like a little, I mean like a dramatic amount. So... according to the guy, this has been heavily modified, and this isn't a true representation of like a pristine varmint. The guy that worked on this added a driver tube to it and a bunch of stuff added to it. So I'm not too sure what we're going to find when we get into the crux of this. Let me get it out of here. Let me get it out of the box. I tell you right now, this is going to be interesting. You can see the other side of this amp, which you'll see here in a minute. You ready? Oh, two more. This is going to be interesting. Oh yeah. Ooh, doggy. I cannot stress to you guys enough how much I dislike working on sweep tube amps. It was keying up and working, then it quit keying, and then they couldn't get it to do hardly any watts. It was exactly what I was described to me. Oh boy. So it started to sound like I was on sideband. He goes, there's a lot of really bad solder work in here. He goes, but this box ran so good. Yada, yada, yada. Okay, well, I guess he added a driver tube to it, and I guess the last guy that worked on it was buying first class tickets on Noah's Ark, you know what I mean? He's 190 years old. This is gonna be interesting. This is one of them deals where it stretches out your Jedi Knight skills, because it's no book. There's no manual, no schematic. Don't know what a guy did. I mean, you just don't know. I don't know if you guys can see it or not, but it's the biggest problem with the sweep tube amps that there is that they're basically made of tin foil. And one, when you get the amplifier on the other end, it's probably going to be busted because the box is so flimsily put together that the transformers will bend and bust the cabinet. But look at our center conductor here. Look at this. This is the center conductor of the coax, and it's shorted to shield and ground right here on the driver tube. So the RF can't even get in. I press down on it and it pops off. I mean, all of this is like this. I'm sure this was working, but the problem is it might have worked great for years. Then it gets here, and man, if I make this work, oh my God, if I somehow make this work and then put it all together and then put it in the mail, how do I know that some of this half-assery that's in here is going to fall apart in the mail? And the guy gets it on the other end and he's going to call it doesn't work. It's 1, driving 3, driving 6. So let's say, okay, I've calmed down for a minute. It took me a minute. I managed to get this board remounted, get the cabinet bent back up square. Let's say I decide to call this guy up and I'm like, okay, I'm going to fix it. I got to completely rebuild this box. And I got to rebuild it to a standard where it's not going to fall apart. I mean, this is 1, driving 3, driving 6 on that. And yeah, this is the kind that was banned in the United States. It's got the fuses in the plug. None of this stuff is bolted down in here. Here, let me... I get that this is the power supply that was added for the driver tube. I get that. Here, look at just the on-off switch. I don't have words. I don't have words. I got nothing. So I just went through and checked all the caps in the high voltage section, checked all the diodes, all that kind of stuff. That all checks out okay. At least it did when I took it apart. So then I go to power it up and it turns on, but it doesn't key, and that's what the customer says, it stopped keying. Well, there's two transistors over here on this board that are down in here that I checked, and they're good. And I went, all right, there's got to be another keying circuit. This is an NPN transistor, and it was tucked down in here, and it's got a disc capacitor that comes off of the input coax. Sound familiar? I'm telling you, all the parts are the same. They're just laid out differently. So if we take and we follow, and I just check this transistor, it's good. So I start jiggling this wire, the gray wire, and look at what shows up over here. This little wire is off. See that? Now where does that hook up? We don't know. We know it's going to be providing a negative signal. So we go and we trace this out, this brown wire here, and it comes over to the OPT standby switch. Okay? And that's this lead, and then it comes out, goes to this capacitor bank, goes through this diode, through this cap bank, through this tap, and then what comes out of here drops onto this relay. But then we've got this yellow wire that takes off and goes over here, and it goes to this over here. Sorry here, let me back up. We got this yellow wire that comes and takes off of this relay bank, comes across and attaches to this relay, and then off of this relay there's another wire that attaches to this relay. So it just simply stopped keying, is what the guy said. I told him on the phone, if I'm able to get this to work for you, I cannot make you any guarantees on if it's going to stay working. He goes, why not? And I said, well, there's so much bad going on in here as far as solder work is concerned. He goes, oh yeah, I looked inside of it. He goes, it's got some really bad solder work. Yeah, it is what it is. Like I said in the previous couple segments, you and I both know that this thing was put together by the guy down the street, and it is a damn miracle. Just make sure it's not touching nothing. It's not. I don't want that disc capacitor and that wire laying on top of each other. Okay. It's a miracle it stayed running, and it's a miracle it made it here. I got all the tubes in it. The driver board, I soldered that back down. I'm just doing the most minimalistic amount of work to this as I can. And so I'm not going to go through and completely rebuild this. This guy can't afford that. It'll be days worth of work. I'm just trying to sort out the minimum of what happened here. Now, there's a diode that goes from here to here. So now we're going to go look here at this relay in the corner. The wire in its relaxed position wants to sit something like so. If I pull the wire out and look at it, it's been hooked and soldered from the bottom then there's a solid jumper that runs across this, I'm assuming is a relay. And this would be the coil side of things. Have to sit and think about this one for a minute. Okay, so we know that this is going to be a negative switch over here. Now that the amp is powered up, so the circuit in here is live. So we're going to only stick our hand in the amp one hand at a time, and we're going to do it at the end of our insulated probe. So we're going to look at this wire, and we see that this wire is hooked. It's got, you know, it's got a hook to it. So it's obviously going around something. I'm sitting here staring at this relay, and I go, well, let's probe here. And I've got 17 volts here. We'll flip the switch into standby. We got 0 volts. So that tells me that this is the positive pole of the relay. And then over here on the other side, there's an exposed nub. Let's turn our variac down. There's an exposed nub with no wire attached to it. And I'm like, okay, well, a relay's got to have positive and negative volts. This is going to be our signal sent source. If I want to put this in standby, I'd cut off the positive side of it, just like on almost every other amplifier on the face of the earth on a 12-volt relay, right? NPN keying circuit is going to spit out a negative signal, so then we know that the input signal going into the relay is going to be negative, obviously. I bet you this wire just popped off. And then we'll go chase the rest of the bag of problems, if there is any that present themselves. This is going to be entertaining. I mean, this is entertaining. So I bled the high voltage off of it. Let's turn this back on. Power on. Bring it up slow on a variac. So we're at 110 volts. When I was looking at the variac, I didn't see what closed. Okay, transformer relay. Tubes are lit. Okay, well, so let's see. Second drive, carrier level. Let's turn you down. Oh boy. All right, so here's the amp in standby. Talk through it. Put it into transmit mode. Got it at AM. Got it in super modulator mode. I'm assuming this is our input drive. Okay. So this is causing the input reflect to go up and down. I just don't see it. All right, let's make sure we got high volts and all that stuff. We're slowly progressing along here. Now by probing with my oscilloscope, I figured out that we got RF that goes into the driver tube, And we got RF that's coming out of the driver tube. So now we've moved on to the second stage, which is this 3-tube rail system down here along this side of the amplifier. Well, there's so much bare exposed, can short over and kill you dead stuff inside this box that I have to shut the amp off and wait for everything to discharge, verify, and then I can move my probe around. If not, I'm going to let the smoke out. And I've got enough headache going on here as it is. So we've gone from the output section of the pre-driver to the input section of the second driver. And I'm kind of curious. I'm not seeing any signal. So did we lose signal from the top to the bottom? Got a little signal on the oscilloscope, but and then this is the tuner for the input to the 6-tube section. There it is. So this is down, and that's up. Yep. Okay. So I got a ton of signal. Oh God. Hello, 1, 2, 1, 2. I got a ton of signal going into the input section. Let's pull the power, wait for the high voltage to bleed off. Let's see, that's this probe here. And let's do this without arcing anything over. It's a goal. Probe here, nothing. Probe here, 200 volts and dropping. Let's go probe here, 50 volts and dropping. Just trying to figure out where we lose signal. We got to go into the 3-tube drive section. So we established got all the filament voltage correct. We've got 1,000 volts on the plate, which is a couple hundred volts high, like 300 volts high, but it's okay, I don't care about that. So it goes in on that rail. It's going to come out. So let's unplug it, variac off, unplugged. Verify we don't have any high voltage before we go and stick our meat beaters in here. 24 volts, 15 volts. Okay, not enough for me to carry anything about. It's going to come out on this rail, or in on that rail, which it is doing. Then it goes, we got a glitch choke to make sure if there's any AC that gets on this lead, goes to the case. That's good. So then the RF is going to come out. This is our high voltage lead. This is our plate choke for our high voltage. And then that comes out. So what's our second stage tuner? Care level, tuner, drive, final, second stage. So this is our input stage. So that means this is going to be, our RF is going to come out, go through this disc capacitor here. Sorry, I was going to go through this disc capacitor here and go into this inductor coil, which then in turn goes to this white wire. It loops around a big giant loop. So let's take and we'll probe here and see if we have any outgoing RF or signal. Sorry, I'm thinking about 14 different things all at the same time. And where I'm probing is like the last thing on my mind. And there's parts of Texas stars in here. There's... Whew. Not gonna lie, I'm kind of doing this for the challenge at this point. Okay. Let's make sure that this is plugged in. Ooh. I'm a little curious why the, where do you go, wire? Go to ground. When it comes to this secondary power supply, I'm a little curious why this light isn't working. I'll wait till it's unplugged, because I know my luck. I'll unplug it and then I'll decide to short out and blow up something else I gotta go fix. This does bug me that we're immediately going into transmit without radio drive. But now I know how the keying circuit works. We can come back and fix that in a minute. I want to see if we can make it make power. Oh, got a little bit of signal. Oh, yes, sir. Hello, 1, 2. Hello, 1, 2. You can even feel the amplifier buzzing a little bit. So I got power going out. I got power going in. I got power. Input signal is making it from drive tube to secondary drive to the output or the input of the final stage. But I have 0 from the output stage to the relay. Okay, powered off. Wait for high voltage to bleed down again. God damn, this amp scares the hell out of me. Okay, this is so unsafe. Make headway. We're making headway. There's a lot of cold solder joints in here. Now, down in here, this mess of melted coax, this thing's on. I got nothing insulated. Yeah, I do here. Is this insulated screwdriver? Right there to there. That's the center conductor of this piece of coax. And if you can see how furred that is, that's all shorted out. We're not going to pay any attention to this lead here. That scares the pee out of me too. But this is on the high voltage side of things. This coil, this inductor coil here, and this runs over to the air tuner. Look right in this area here. Hello, 1, 2. Even with us losing that much drive, we're making 400 watts of power now. This was shorted out down here. So right now, hello, 1, 2. I've got to repair that. And maybe we'll get a little bit more out of this. But it is working. But that was shorted completely out until I started dicking around with these leads down here. It wasn't doing anything. This is, I can see I'm going to have to be replacing some coax. I'm going to have to rework a couple things in here for me to at least feel safe to give this back to the customer, because I know he's going to try and use it again. Start here. So what I did is I went in and I replaced all of these coaxes that looked like refried dog doo-doo. That's, to me, scary as frig, but it's got brand new RG316 in it, everywhere that it's supposed to have, like a good connection for coax. Now, this is RG, what is this? It's labeled on it. RG62A, which is 93 ohm coax. I just don't see it. Like here, let's look at this. Let's go to manual focus. Look at this. you get so much bad stacked on top of bad. I mean, it just, some kind of weird miracle that's worked, okay? Or this here. If you look really close, you'll see that there's actual little pieces of wire touching here. So, and then like this refried dog dude here, I got rid of all this stuff, made it go away. And then I started having some progress. The inductor coil, which is here, I took a piece of wire and came from the bottom. So I wrapped it through the eyelet, then came through the bottom and then wrapped it around the inductor. So that's got a physical connection to it, an inductor. So, I mean, this amp still scares the hell out of me because there's a lot of different things that could short to the case. And this is an ungrounded plug, okay? Very dangerous. Very dangerous. Very, very dangerous. But, oh yeah, even fixed the light bulb. Even fixed the light bulb. So now, doesn't jump into operate right away. We fixed that as well. So we'll leave it in standby. Now over here, we have ourselves a 1,000 watt slug and peak, 1,000 on average, and a 5 watt slug and reverse back from the Bird 10,000 watt dummy load. We're in 1X, or otherwise 1,000 watt. Hello, audio. Okay. So we're putting about 20 watts into it. Hello, 1, 2. All right, that's what we look like on the spectrum analyzer. So, there was so much stuff like out of tune. The load capacitor on the front of this thing, its capacitance value was only out by 230 puff. I couldn't get it to do over 450 watts. So you got to remember, the driver tube on this amp is weak. The final section tubes, as we tested, are all over the place. They're like 20, 30, 50%. Or the final tubes, the driver tubes are like 80 to 75%. So I can only imagine what this box would do if it had a full good set of tubes in it. But remember, the only reason it came in here was because the customer stated it quit keying and then didn't work again. So let's reach down here, put it into operate. Hello, audio. Oh yeah, it went off the chart. Hello, audio. Hello. 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 Let's take a look at it on the spectrum analyzer. Hello, 1, 2. Hello, 1, 2. So we have a little bit of a secondary spike going on there, but it's way down there. It's like 50 dBm down, so I'm not, or 50 dB down, so not too excited about that. Hello. Hello, audio. I mean, we're slamming it off the end of the scale. So let's go over here and we'll put this up on 2X. Hello, audio. Hello, audio. Hello, audio. 1, 2, 1, 2. 1, 2, 1, 2. Hello, audio. Hello. Stupid little sweet tube boxes. You can always hear us at the other guys on channel 5, or they'll be up on channel 7 tuning these things out when they're trying to run them on the bowl. So it did not work at all. Came in here, death trap's going to leave here, death trap. The on-off switch in the front did not work. It did not key up, and you could not make it make any power. Now with the 6 tube section, I mean, this should do more. This should do about 15 and some change, 16 and some change with a good set of tubes in it. But remember, it came in here not working, complete hackify. And it's going out of here with some very low tubes in it, but still making 12-ish, 13-ish, 100 watts of power with a 20 watt radio hitting it. And it's relatively clean-ish. So I'm going to call this a win. This guy's going to have to come pick this up, and I cannot guarantee him that it's going to work 10 minutes from now. I can't. You guys seen the solder work on the inside. It's scary. So, but we're going to call it a win. XL1000 heavily modified Varmint. This is the scariest Varmint amplifier I have ever worked on. By the way, guys, I don't work on sweep tube amps that often. The parts are too hard to find. The tubes are getting too expensive. A lot of them show up here and they look like this. The construction of the amplifier makes it such that it makes it very delicate for transport, and it has a very high rate of damage en route. And then everybody wants to do an insurance claim. There's no place to send it to get parts or have any idea what it's going to cost to repair. I only work on these if it was like your uncles, your cousins, your moms, your aunts, something like that. It's got some serious, strong sentimental value to you, and I feel like you're legit. Then it'll come here and it'll sit here for like a year and a half until I'm able to take a look at it. So anyhow, done. Walking away. Gentlemen, I'll see you. Thank you from the bottom of my heart. Click, click, click.